Hello, everyone. My name is Qian Liu. I'm from a Department of Applied Computer Science. I'm now an assistant professor, and here today I will present our work together with my TA Max. So the title is Enhancing Artificial Intelligence Education with the Robot Arm. So I joined the university in 2023, September, and then I developed a new AI course. Before that, we don't have that course because AI is still a new topic. First two terms, it was delivered as a topics course in a department. First is winter 2024. I had 7 students in my class, and in winter 2025, I got doubled numbers of students in the class. And this year, this fall term, the course has been finalized as a mandatory course in our department, and I got 41 students this year. And the title of the course is Introduction to Artificial Intelligence, a formal title. And course outline is here. So when we're talking about AI, I think a majority of people understand it as large language models now because they're very popular. But artificial intelligence is more about that. I designed the course in a more traditional way. Start with traditional AI agents, not involve any machine learning or deep learning in it, just how we make the machine more intelligent using some traditional well applied algorithms in the industry. For example, the search algorithms in different environments, simple or complex environments, or in the game settings, and then some traditional and very well used algorithms and well setting the problems, which can be solved using artificial intelligence. And I also talked about reinforcement learning, which is a more advanced AI algorithm, and touch a little bit about deep learning and the natural language processing, large language models as well. So when I was teaching the problem formulation, like how can we make machine smart or intelligent in solving real world problems? I used so the first thing is to transform the real problem into a math or computer problem, so computers and algorithms can solve them. So this is the problem formulation. Then I use the robotics as an example to show them how we can transform the real world problem to a math problem or a computer science problem. So this is the example I was using. We have a robot arm, which can be used in factory assembling tasks. Then we have different joints of the robotic arms, which can be put in a status to describe the problem. So we have the real values of the joints coordinates, and we have the objects of the parts. Then we have some actions, which is we can twist the joints, change the degrees to reach the parts and put them to the places. And we want to calculate, use the algorithm to calculate the best path to get the parts assembled. So that's how we formulate the problem. We can change those joint degrees as numbers and then use algorithm to optimize them. Then I got feedback from the students. They said this kind of algorithm is quite interesting, but if they can have some hands-on practice, that would be great. So they can really see some physical interactions or see the robot arms move and grab things. So instead, if we can have access to a real robotic system, that would be really awesome. So I kind of developed this idea together with the students. I got feedback from the classroom, and then I searched online. I found a nice MyCombo 208 with the AI artificial intelligence kit with a camera here and some actors which can grab things, move things around. And then I applied the experiential learning funds, and I got funds. So I'm really thankful for providing the funds to support this project. Then I think I started the first year when I was teaching this course as a topics course, and then this project hands-on practice was first done in this term, in the fall term. Because I had 41 students, I have to divide them into 5 groups, and every 2 weeks, one group of students will stay after their regular lectures, stay in the classroom, and to do their hands-on practice with the robots. So this is a picture of their doing, really observing the robotics, and later they will do their hands-on. So the hands-on practice include first a brief introduction presentation given by the TA, and then some demonstrations. We designed, the TA has designed 4 activities. He's gonna introduce this later by himself. And then after that, students will engage in a hands-on practice and explore, ask more, or develop. They're imagining what kind of other activities we can design in the future, if that's possible. So I will hand it to Max.
Thank you. My name's Max. Next year will be my final year in the Applied Computer Science program. And Professor Liu approached me after I took her course when it was a topics course to help her create a demonstration for her other students to get more hands-on experience with kind of AI and robotics. I think a lot of, at least in computer science, there's a lot of issues in general all over where the courses can be very abstract. So a lot of hands-on things are great. So here the slides are just the presentation slides that I created. So I tried to get the students involved by asking them a question about where they may have heard or seen about robotics. There's a very famous one there, Canadarm, that goes into space. I did describe a little bit about the cobot, the robot we were working with. Had 6 degrees of freedom. Then I guess the big thing for computer science is development. So how do we actually, what are the tools we can use to create programs? So there's a lot of options with the MyCobot, and I had to learn about 2 of them here. So MyBlockly and ROS are not things that we would typically learn in our degree. Python is a language that we use for the course, so I was already familiar with that, but I was able to get some experience with those 2 development environments. And MyBlockly is just a simple kind of drag and drop coding thing to make it easier to develop simple programs with very little effort. And there's kind of Python and some ROS, which is this is an industry standard ROS, so it's used on all types of robotics. You can do quite a bit with it. I didn't get to play around too much with it because I didn't have a lot of time to prepare or enough time to learn that and prepare a demonstration for the students. Let's go next. I did mention to the students, because there's quite an important difference to, I guess, the actual execution of movement and the actual planning and decision making. So AI is more focused on the planning and decision making. And a lot of these algorithms here, BFS is the one that is an example of, we were actually learned in class and we get to program them and experiment with them. But I wanted to make the students clear that there's a little difference between the execution, and that's where this kind of inverse kinematics comes from. It kind of calculates how the angles needed to pick up, let's say, a block or something like that. And then there's some interesting things there. So I set up 4 kind of demonstrations, kind of expanding the scope of the robot. So we started with the MyBlockly, just getting it to move simply, making it wave. And then I personally made the breadth-first search algorithm. So we just did like a 3x3 grid. The robot was aware of the locations of the grid, and we placed a cube. And with it, it did a breadth-first search and found the block and picked it up and moved it. And then I also showed them a computer vision technique, 2 of them, one with which is not really an AI related one, but is quite simple, and then one that is more AI related. So they really got to see the real applications of AI. I think that's it.
The future where so the robotics are there, and I can use it every year. So each year we'll develop different activities and test the different algorithms, and if students are interested, they can. I have already got 1 student stay with me for summer research on robotics, and they have indicated that they want to stay here to do master with me. So, that's all for our work. Thank you.
Thank you.